Good morning, children. This is 8th standard maths lesson cubes and cube roots. So, in the last video, we have studied how to find whether a given number is a perfect cube or which is not a perfect cube. So, let us continue the chapter cubes and cube roots with exercise 1.1. So, first is over. Now, the second question. Find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So, we have to find the smallest number by which these numbers must be multiplied so that we will obtain a perfect cube. We know that the numbers obtained when a number is multiplied by itself 3 times, they are known as cube numbers or perfect cube. And we also studied in the last video 1 to 10 what are the numbers coming under perfect cubes. So, in today we shall learn how to find the smallest number so that when you multiply to this particular numbers we will get a perfect cube. Okay, let us solve the first problem, that is 243. Now, the first step in this problem is find out the factors of 243 through factorization. So, let us factorize 243. Okay, so we have 243. 243, it goes by 3. 3 8s are 24. 3 1s are 3. Again it goes by 3. 3 2s are 6. 8 minus 6, 2 is remaining. Therefore 21. 3 7s are 21. Then 3 9s are 27. 3 3s are 9. 3 1s are 3. Therefore, through the prime factorization, we got 243 is equal to, count the number of 3's obtained. 1, 2, 3, 4, 5. So, we obtained 5. So, 3 to the power 5. So, 3 into 3 into 3 into 3 into 3. So, 1, 2, 3, 4, 5. Now, what is the next step, children? The next step is we have to group the numbers into 3 such that it forms a group of 3 digits. So, while counting here, 3 into 3 into 3. So, it is 3 cube into 3 into 3, where we obtained 3 square and it does not form a group of 3. So we know that in the prime factorization of any number, each factor, if it appears 3 times, then the number is called as a perfect cube. Whereas in 243, the prime factor 3 does not appear in a group of 3. Okay, because we have 3 square. One more which we have is 3 cube into 3 square. 1 appears in 3. Therefore, first factor, that is 3, appears in a group of 3. Whereas the second group in which it does not appear in a group of 3. Therefore, 243 is not a perfect cube. So, to make it a cube, we need one more number, that is 3. So, it becomes 3 cube. Therefore, children, in the next step, this 243 has to be multiplied with the smallest number 3, because we are not forming a group of 3 in this prime factor. So, when you multiply 243 into 3, we are obtaining 729. So, 729 is a perfect cube because 9 into 9 into 9. So, 9 when you multiply by 3 times, you will obtain 729, which is a perfect cube. Therefore, when we multiply the number 243 by 3, we will obtain 729, which is a perfect cube. Therefore, children, the smallest number by which 243 must be multiplied to obtain a perfect cube is 3. This is the solution to the first problem 243. So when a problem is given to find out the smallest number by which we have to multiply to this number so that we will obtain a perfect cube. So first factorize the number. After factorizing, group that such that you have to get a group of 3. So now in a prime factorization, check which factor will not appear 3 times. Then to that which factor, the number which does not appear 3, take that number, multiply to the given number. So when you multiply, you will get the perfect cube. Then the answer will be that the which smallest number you multiply to the given number, that is the number to obtain a perfect cube to the given question, that is 243. This is the first question. Now let us move on to the second question, that is 72. Now we have to find which is the smallest number to be multiplied to 72 so that we will obtain the perfect cube. So what is the first step, children? Yes, we have to factorize 72. So let us factorize now 72. So 2, it goes by 2 because 72 and it goes by 2. Since you had 3 in the unit place, it should be 3. Okay. Now we have 72. So it goes by 2. 2 3s are 6. 7 minus 6, it is 1 here. So that it will be 12. So 2 6 are 12. Again it goes by 2. 2 1s are 2. 3 minus 2, 1 is remaining. So 16. So 2 8s are 16. Then it is again 2. So 2 9s are 18. 9, it goes by 3. 3 3s are 9. 3 1s are 3. Therefore, through prime factorization, we got 72 is equal to 2 into 2 into 2. 2 into 2 into 2 into 3 has been repeated 2 times. So 3 square. So 3 into 3. Now group the digits. 2 into 2 into 2, it is 2 cube into 3 into 3. So it is 3 square. Therefore, the prime factor 3 does not appear in a group of 3. Therefore, this 72 is not a perfect cube. So in order to make it a perfect cube, what do we need, children? We need one more 3. When we get one more 3 in this group, then it is a perfect cube. So the question is, which number you have to multiply to the given number. So since the prime factor 3 does not appear in a group of 3, then we have to multiply that 3 to 72. So when you multiply 72 into 3, you will obtain 216, the answer. So 216 is a perfect cube because 6 into 6 into 6. You will get 216. Therefore, 216 is a perfect cube. Therefore, the smallest number by which 72 must be multiplied to obtain a perfect cube is 3. This is the solution to this problem 72. The next problem is 675. So first factorize 675. So it's 675. Since we have 5 in the unit place, it can either go by 3 or 5. So let us consider first, that is 3. So we have 3 2s are 6. Okay, 3 2s are 6. 7 minus 6, 1 is remaining. So 3 5s are 15. Now again we can try with 3. So 2 is lesser than 3. So take 22. So we have 225. Therefore, so 3 7s are 21. So 22 minus 21, you will get 1 remaining. Therefore, 3 5s are 15. 75. Now again we can try with 3. 3. 3 2s are 6. 7 minus 6. 1 is remaining. 3 5s are 15. So we have 25 now. 5. It goes by 5. 5 5s are 25 and 5 1s are 5. Therefore, through prime factorization, the factors of 675 can be written as, count the number of 3's obtained. So, 3 into 3 into 3 into 5 has been repeated 2 times. Therefore, 5 into 5. Now, group it. So, 3 into 3 into 3, it is 3 cube, into 5 into 5, it is 5 square. Okay, now you consider, children, the prime factor 5 does not appear in a group of 3. Therefore, children, 675 is not a perfect cube. So, to make it a cube, what do we need? We need one more 5 to be multiplied to the group of 5. So that in the next step, 675 into 5, the smallest number which does not appear in a group of 3 is 5. So 5 has to be multiplied to 675. So when we multiply 675 into 5, we will obtain the answer 3375. 15 into 15 into 15, that is 15 cube is equal to 3375, which is the perfect cube. Therefore, the smallest number by which 675 must be multiplied to obtain a perfect cube is 5. Therefore, this is the method how to find the smallest number by which the given number must be multiplied so that we will obtain the perfect cube. This is how is the method. Now let us solve the third question. Find the smallest number by which each of the following numbers must be divided to obtain the perfect cube. So in the second question was the given number to be multiplied so that we will obtain the perfect cube. Whereas in the third question we have to this given number which is the smallest number to be divided so that we will obtain a perfect cube. To understand this concept, children, let us solve the first problem, that is 81. Now, first let us find out the factors of 81. Let us factorize this 81 number. So, since 1 is in unit place, it goes by odd number, that is 3. So, 3 2s are 6, 8 minus 6, 2 is remaining. So, it is 21. So, 3 7s are 21. Then, 3 9s are 27. 3 3s are 9. 3 1s are 3. Therefore, through prime factorization, 81 will be equal to, count the number of 3's, 1, 2, 3, 4. 3 into 3 into 3 into 3. Now, form a group. So, 3 into 3 into 3. Therefore, 3 cube into 3 has been repeated only once. Therefore, in the prime factorization, the prime factor 3 does not appear in a group of 3. Therefore, this 81 is not a perfect cube. So, in order to make a cube, we have to divide this 81 by 3 because 3 has been not repeated 3 times. So, the given number has to be divided by 3. So, 81 divided by 3. So, 3 1s are 3. Then 3 2s are 6. Okay, 8 minus 6, 2 is remaining. So, 3 7s are 21. So, whether 27 is a perfect cube, children? Yes, 27 is a perfect cube because 3 cube is equal to 27, which is the perfect cube. Therefore, Therefore, when 27 is a perfect cube, therefore the smallest number by which 81 should be divided to make a perfect cube will be 3. So, 3 is the answer. So, next take the second question, 128. So, to find out which is the smallest numbers to be divided to 128, so that we will obtain the perfect cube, let us factorize this 128. So, when we factorize 128, it goes by 2. 2 6 are 12, 2 4s are 8. Again by 2, 2 3s are 6, 2 2s are 4. Then 2 1s are 2, 3 minus 2, 1 is remaining 12. So, 2 6 are 12. Then 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. Therefore, through prime factorization, 128 can be written as, count the number of 2's obtained through prime factorization. 1, 2, 3, 4, 5, 6, 7. So, 2 into 2 into 2 into 2. So, write 7 times. 4, 5, 6. It is 7 times. Okay. Now, form a group of 3. So, 2 into 2 into 2. Okay, it is 2 cube. Next count another 2 into 2 into 2. Yes, of course it is 2 cube into 2 to the power 1. Therefore, in the prime factorization, the prime factor 2 does not appear in a group of 3. Therefore, 128 is not a perfect cube. So, to make it a cube, we need one more 2. So, what do we have to do is, we have to divide the given number 128 by 2. So, when we divide 128 by 2, 2 1s are 2, 2 6s are 12, 2 4s are 8. Therefore, 64. 64 is a perfect cube because 4 cube, 4 into 4 into 4, it is 64. Therefore, 64 is a perfect cube. Therefore, the smallest number by which 128 should be divided to make a perfect cube is 2. So, children, this is the answer. So, 64 is obtained as a perfect cube when we divide 128 by the smallest number 2, which does not appear in a group of 3. Then, the smallest number by which 128 must be divided to obtain a perfect cube is 2. This is the answer. The third question is 704. So, first, let us factorize 704. So, 704, it goes by 2. 2 3s are 6. 7 minus 6, 1 is remaining. 2 5s are 10. 2 2s are 4. 352. Again, it goes by 2. 2 1s are 2. 3 minus 2, 1 is remaining. So, 15. 2 7s are 14. 15 minus 14. Again, 1 is remaining. So, 2 6s are 12. So, we have 176. Next, 2 8s are 16, 17 minus 16, 1 is remaining, 2 8s are 16. Then 88, it goes by 2 again. Therefore, 2 4s are 8 and 2 4s are 8. We have 44. So, it again goes by 2. Therefore, 2 2s are 4, 2 2s are 4. 22, it goes by 2. 2 1s are 2, 2 1s are 2. Therefore, we have 11. Then, it should be with 11. 11 1s are 11. Therefore, through prime factorization, this 704 can be written as, count the number of 2's obtained, children. 1, 2, 3, 4, 5, 6. So, 2 to the power 6. So, let us write 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. 4, 5 into 6. So, 2 to the power 6. Then, we have 11, which is appearing only once. So, 11. Now, when we group 2 into 2 into 2, it is 2 cube into 2 into 2 into 2. Again, it is 2 cube into 11, which has appeared only once. Therefore, in the prime factorization, the prime factor 11 does not appear in a group of 3. Therefore, 704 is not a perfect cube. Therefore, to make it a cube, we require one more 11. Therefore, this 704 will be divided by 11. So the question is, which is the smallest number to be divided to the given number? Therefore, 704 divided by 11. Therefore, 11 ones are 11, 11 sixes are 66. 70 minus 66, the remaining is 4. Therefore, then 11 fours are 44. Therefore, 64. 64 is a perfect cube because 4 cube. 4 into 4 into 4, it is 64. Therefore, 64 is a perfect cube. Therefore, the smallest number by which 704 must be divided to obtain a perfect cube is 11. So when we divide 704 by 11, we will obtain 64, which is a perfect cube. Therefore, 11 is the smallest number. So this is the method how to find the smallest number to be divided to the given number in order to obtain a perfect cube. Thank you, children.